Guys, welcome to my apartment. This is a set of keys to my apartment, and my apartment is full of things, and it is very expensive and very small. Then I have another set of keys to another place, a storage system. It is also packed with a lot more things, and that storage place is way more cheaper than my apartments. Sometimes I want to ask questions to the storage systems. For example, I want to know how many things are in the storage system without moving those things to my apartment. That is what Spectrum is all about. So my apartment is redshift. It keeps things, but it is expensive to keep things there. Then the other storage system is S3, and S3 you can keep a lot of things cheaply, but sometimes you would want to query data from S3 when you are in redshift. That is what redshift Spectrum brings to the table. Redshift Spectrum. Let me explain this the best way Sammy can understand. I know Sammy, you are watching, so this video is for you to understand what Redshift Spectrum is about. Redshift is a warehouse, and the data warehouse solution offered by AWS, and S3 is a storage system where you can store anything. It's just an object storage system. You can store there your Excel files, you can store there your pictures, you can store there your Word documents. And then Redshift is a collection of databases, and they are collected in a cluster. So you can look at Redshift as a house, an apartment, where you have different rooms, and in those rooms are synonymous to databases. They all work together to solve a particular purpose, and the data that is stored there is structured. By structured, I mean there is rows and columns. In S3, the data that is stored there can be structured, that is rows and columns like Excel, and it can be semi-structured, where you have rows, columns, and then some rows can have other columns inside them. And then data can also be unstructured. For example, a movie file, an image, and so forth. So unstructured data, structured data, all those objects can be stored in S3. So if you're watching a Netflix movie, likely that movie, the movie file, that video file was stored in an S3. If you're looking at an image on most of the sites that use AWS, that image is stored in S3. And then Redshift is a solution that is used for analytics, so that you can do query. You can query lots of data easily and quickly from your cluster of databases. Now, Redshift is expensive, and having more compute and more storage on Redshift, it costs more. But S3 is not as expensive as Redshift. And sometimes you have data that you don't need to be reporting on frequently, and you want that data to be stored somewhere else away from Redshift. There is where you have S3 as a solution, where you can store that data. So you can store that data as CSV, as Parquet files, as JSON files, depending on how your architecture is and how you want to read them. Most of the time we store them as Parquet files, because Parquet is columnar and we can read columns. Columnar, Sami, is data is stored in a column format, and we can choose particular columns to read. So you don't need to read the whole file. You can just read, let's say, gender, and you can read age, you can read, and so forth. If you want to select 3 columns from a file that has like 1,000 columns, you can only select 3, and it doesn't cost you more than if it would have costed you reading all the data that is in packet format. But what is important for us now is data is stored in S3. It is data that you rarely read, but at some point you may want to read. It's like the example that I started with. You have your apartment, it is very expensive, and you have S3, which is a storage place where you store things that you rarely use. So if you have 5 motorcycles and you rarely use all of them, they're like vintage. I know you like motorcycles, and some of those vintage motorcycles you just go take them for showrooms and you rarely use them. Those motorcycles, you can keep them in your storage system that is in your S3, but when you want to use them, you can pull them, maybe call the tag, understand when it was created, and so forth. So once you are in Redshift and you are working with Redshift, sometimes you want to pull in that data, you want to read that data, or you want to query that data that is in S3, but you don't want to pull in all the data that is in S3. AWS or Redshift gives you a solution, and that is Redshift Spectrum. So Redshift Spectrum is a solution that connects your Redshift instance to S3. And now you will have capability of reading the data in S3 and combining it with the data that is in Redshift to come up with an analytics that is combining both sets of data. It's good to note that when you have Redshift Spectrum, it is not a database, it's just a map. It's just a definition of how the data should look like and where the data is. So the data is defined by something called glue, and in the glue there is catalog on how the data looks like. So is it integer, is it a string, how big is it, how is it partitioned? So you may have your data partitioned by day and so forth. That is defined in glue. And then Spectrum gets that definition, reads the data, looks at the query that you've given it, returns only the information that you are running in the query, combines it with the data that you have in Redshift if your query is reading also local tables. Oh, there is local tables and there is external tables. Local tables are tables which are defined in Redshift. So you already defined a table in Redshift and the data is stored in Redshift. So you have data pulled into Redshift and it's kept in Redshift. Those are local tables. External tables are the tables that are defined in Redshift Spectrum. In Redshift, they look like tables, but the data is not stored in Redshift. The data is stored in S3. And this is where we look at the difference between schema on read and schema on write. Schema on write, you first define the schema when you're creating local tables. By schema, I'm meaning the column, the name of the column, the data type, the size, and so forth for each table. And then you write the data onto the table in Redshift. That is schema on write. Now, schema on read is the data comes into the storage system in any format that it comes with. Can be JSON, can be CSV, can be Parquet, can be anything. And you don't mind how the data is stored. But when you want to read, you first define the schema. You have selected columns that you want to read. You define the data type that you want to read, and so forth. So that is schema on read. You first have the data stored, then you read it. So those are the two. So you have external tables. It is schema on read. Then local tables are schema on write. So I hope I have explained Redshift Spectrum properly to you, Sammy, because I know you don't know AWS. So hopefully this is enough for you for this week. If you want me to show you this as a tutorial, how to first of all set up redshift. I know there is a video on how to set up redshift, but setting up a simple redshift instance with S3 and then show you how to move data to redshift with schema on right, and also creating a redshift spectrum with schema on read and having the data show, and then doing some simple analytics. You can write in the comment. If Sammy write in the comment, I'll not do it. I want someone else to write only one comment, then I'll do it. Until next time, thank you for listening to me. Hopefully you've understood redshift spectrum. Until next time, keep learning.